Hello everyone, it's Dr. Wolfe here, and in this video I'm going to be explaining how substances move across a membrane in order for a neuron to send its electrical impulse down its axon. So let's first start with our stage. Setting the stage, we have our cell membrane, our plasma membrane. It's made up of a lipid bilayer. Out here is going to be the outside of the cell, that's our extracellular fluid, and then we also have the inside of our cell, so this is our cytosol here. Now, our reddish-orangish pieces, these are going to be our solutes, so we can imagine that the rest of like this space here, like the wood, would be just water, right? Now, specifically, this is going to be sodium, all right? And sodium, all right, its relative size is actually pretty large compared to other elements, so it has a tough time maybe getting through the membrane, but that's not the biggest reason. It's also a polar molecule that has a charge, so sodium's not going to be able to pass through the membrane on its own, all right? Also, right now we are at equilibrium. There's an equal amount of sodium inside and outside the cell, okay? And what we want to do is we want to build a concentration. We want to get rid of this equilibrium. We want to build a concentration gradient and get a high concentration of sodium outside the cell and a low concentration inside the cell. All right. How are we going to accomplish this? All right. Well, remember, molecules want to naturally move until they reach equilibrium. So this is actually where sodium wants to be. So if we want to create a concentration gradient, we have to have an input of energy, right? In order to make that happen, this is what we call active transport. So ATP is going to attach to this sodium pump. Think pump like you have to use energy to get water up from a pump. So that's going to be our sodium pump. Once we have that ATP, that'll change the shape of this protein to open up, and then it'll send sodium out into the extracellular fluid. Now, in reality, it's you have to have multiple ATP molecules coming in to make this happen. All right, but what I'm doing right now is I'm building my concentration gradient. So ATP all going through our sodium channel. All right, so right now we do have a low concentration of sodium inside the cell, a high concentration of sodium outside the cell. All right, and I'm just going to bring some of these cards away to make it easier to kind of see what's happening now. Okay, so then we're going to get to part two. All right, what is, all right, coming from the left, all right, is the charge of our cell right here, all right, just became a little bit more positive, all right? What that causes now, because we have that charge became a little bit more positive, it causes this sodium channel to open up, all right? So now that sodium channel is opened up, which way do the sodium molecules want to move? They want to go from a high concentration to a low concentration, right? This is passive transport because it requires no energy for the cell at this point, right? The cell's already put in the energy to create that concentration gradient. Sodium's going to just want to naturally move this way. This is an example of diffusion. Now, specifically, though, because it can't just do it by itself, it needs the help, the facilitation of the sodium channel. It's called facilitated diffusion, and that's exactly what happens. The sodium rushes in because there's a high and low concentration. Also, though, because the sodium's charged, it's got a positive charge, negative charge inside the cell, it rushes in. Not only, all right, is it rushing in, but it's causing this, like if we have this influx of this positive sodium coming into our cell, well then it's changing the charge of this part of the cell right here. Remember earlier, there was a positive charge over here. By the way, that was caused by the exact same thing happening right here. Now there's a positive charge over here. So what's going to happen at the end of part two is that change in charge right here is going to cause the same thing to happen just a little bit down the line. Now this happens in like the tiniest bit of milliseconds. This is an electrical impulse. So it's essentially like a wave of these sodium channels opening up, right, sending this positive charge down the axon, and that's how our neurons communicate with each other. Thanks for watching.